that would involve drawing. So I always say that you should make a kind of semantic drawing of whatever like process we're speaking of, because drawings are going to be help us explain things pretty well. It makes our life easier, but also thinking of charts or drawings, we need to be able to explain what they are. So partly what can happen in an exam that I give you a drawing or kind of image and you should tell me what you see there, or you should support your explanation with a little drawing. This is also useful because then you need to speak or use language, written language less. So maybe if you're not that good in English, with a good drawing you could help me explain already what you're speaking of, what you're talking about. And here then I want to speak a little bit about the material of lecture number 2. Lecture number 1 was about climates, and well, in that case there will be only perhaps a very little bit of like material that would appear in the exam or the test from the lecture 1 about climates. Instead, lecture number 2, when we were talking about species and also why we have so many species in, for example, the tropics, so in the tropical areas like Amazonia, Indonesia, or Central Africa, or some of these biodiversity hotspots which are related or closer to the tropics. And here we had these kind of hypotheses. So what is the reason for this? And there were two sets or two different kinds of hypotheses that scientists were speaking of perhaps more in the past, and what we're speaking more perhaps today. So these were the abiotic hypothesis and the ecological hypothesis. What is the difference between them? Well, abiotic are more like of geography, looking at geography as being the reason, and they're also called in a way the historical hypothesis, which in two ways would be valid. Historical, as today these are not counted as so relevant. We don't consider these as the main possible reasons for the richness in biodiversity. At the same time, history means that there are bits here of long-term stability or ice age refuges. So looking at the history of this area, how it has been developing in the past couple of thousands of years or even longer. So those would be the abiotic hypothesis to the richness of biodiversity in the tropics. At the same time, we can speak about the ecological hypothesis, which are more about thinking in terms of biology and how species behave and interact. And one of the things that we've been speaking about is more resources. So then we have a bit of drawing as well, less seasonability, of course, and more bio-interactions, which is about development of different niches. So these all are the ecological hypotheses, which we might say that possibly would have a higher role in forming this richness of biodiversity in the tropics. But what I want to speak here a little bit, because there's some drawing we can do, is the ice age refuges. So what was this about? And the example that was shown in the PPT is like South America, which I just draw like something just like this. It was, and here we were speaking about the tropical zone, so somewhere here, Amazonia especially we can think of, so the northern part of South America. And so how can we imagine these ice age refuges to develop? Well, overall, if I just want to highlight this area, so the northern part of South America, so the tropical zone, perhaps this is where the equator would be crossing South America. So in this area, perhaps we say that originally we had like a kind of forest that was covering the whole area. So we can say that the whole environment was dominated by the same kinds of vegetation. We might say that there was a lower kind of biodiversity or number of species that we would have now. And we say that during the ice ages, to some extent with cooling, and perhaps we can also say here that, as we know, the northern hemisphere had this kind of cooling in the ice ages where we had the mammoth steppe. Here we didn't have actually a steppe, but more like a grassland. So the original forest dominated landscape has been, to some extent, been wiped out. And so we might say like this: some of these individual areas have developed where we find more like forest vegetation, and in between we'd have savanna. So there were some of these remains of the original forest dominated landscape, and there were, as we call these, the refuges, some of those areas that remained, capturing the original wildlife, the original species. And these individual areas became isolated, so they were cut off by the grasslands in some of these areas. And of course, as we know how species would develop, allopatric speciation especially, so these acted what were like grasslands. These acted as like border lines or barriers, and then individual areas could further on develop in different ways. So species started to be developing further and changing in their own little areas. But later on, with the changing climate, what we have seen is that, again, these areas that were then turned into grassland, the climate became warmer, became wetter. So these areas then turned into something that we would call forest dominated once again. If we think of like Amazonia, what is Amazonia now? It's a tropical rainforest. And at the same time, it's not only just some of these species that originally were there, perhaps spread out again, but at the same time, and I just show here little arrows, so those species that developed in the refuges also spread out into the wider area. So these little arrows would show that they started dispersing And so then we have these different species that would be all around one of that one over here as well. This one would be like that. So what we would see originally is rather boring. And now we would find much more species in the original area that spread out from the individual refuges. Now here in the PPT, we also have some drawing that we can do based on the pollen evidence. So what is pollen? Pollen is, in Chinese you'd call it like the huafen, is it? So pollen evidence would be about capturing individual species, numbers basically in different areas, and how this kind of like drawing would show the changes is that we have this vertical axis where we speak about downwards time and also depth. So we can say that here we dig down to a couple of meters. I just put here randomly 2 meters, and this is the surface, so this is 0 meters. But at the same time, this would be about the development or the accumulation of soil. And so here we can say that this is also representing time from older to younger. So I just put old and young. So young is on the top, old is over there. And what we can do is, in different locations and for different species, have a look at how many of these are present. So how much of the pollen can we identify? And for this reason, when you see that there is this chart, we can say that there are some of these like trees, different tree like species. Also we would have some of like plants like grass, another kind of grass, and maybe we can say there's another kind of like tree here. And how do we find, or what do we find if we dig down into the soil, is that historically different amounts of these pollen would be found. So here we can say that for this species of tree over there, originally we had a lot of this material here. Again, a lot. But there was a certain time in history over here when this species started to perhaps decrease or be found less in this area. So some of these little lines or these curves which shows something like this in the PPT would mean that these species started to, perhaps at this time in history, disappear. But we can say for other species as well, that depending on how thick these lines are, how many of these species would be, or how many of these individuals of this species would be present. So we can just draw something like this. And again, perhaps the pattern is similar by time. Perhaps this is when the global cooling happened. This species as well started dropping in numbers. And for other like plants such as these grasses, we said perhaps in the beginning there were less, maybe not even any. And by time there became more and more. There was a time when these were really dominant compared to the trees. And perhaps there was again a time in history when their numbers started dropping as well. something like this. And we can do the same for other species as well. Another little grass here, which perhaps was dominant throughout time, but then only recently it started disappearing. And then we have here another tree, which we can say that was perhaps only present in the very beginning. Then it disappeared, nothing over here, and then it started appearing again after the ice ages, so some of the historical global warming. And perhaps I can draw over here as well the appearance of these arborescens, so some of these trees, maybe here as well, showing that the climate change actually meant that some of these species were returning. So this is where we say that there is ice age, when most of the grasses were dominant and trees were less present in this area. So this is just to explain how we can read or how we can understand these drawings or charts about the pollen data.